Thank you so much, Volker. Thank you, Dan. It's a real pleasure to, well, I was going to say to be here. It would be even more pleasant to be where you are. But thanks so much for showing up, for coming. And I will now share my screen with you and then talk from these slides. So I hope that everybody is seeing a slide with my title on it and my name. If not, please screen now. Okay, good. So again, thanks very much for coming. So this talk is called Frege, Caesar, and Hume's Principle, and it will become clear why it has such a silly name. If you're interested, there is an essay that has a lot more detail from which this talk comes. It's not out yet. You can see it's in this this nice volume that Francesca Boccuni and Andrea Sereni are editing. And if you want to see a draft of it, it's up on my website. What my website is, I have no idea. I can only find myself by Googling myself, but that seems to work. Okay, sorry. So Hume's principle, as probably most of you know, is just this principle that says the number of F's is identical with the number of G's if there's a bijection from F onto G. The interesting point for our purposes is a point emphasized by many people, by Crispin Wright and by Frege himself, perhaps by Richard Heck, that Hume's principle plus fairly uncontroversial second order logic suffices for the proof of what Frege took to be the fundamental arithmetical laws, essentially the second order Dedekind Peano axioms. And so the following question is raised, and it's been raised largely since the work of Crispin Wright. When Russell's paradox undermined Frege's logicist project, why didn't Frege just give up on his theory of extensions or value ranges and take Hume's principle to be either an axiom or a definition or something like that, and then proceed as before, proceed in fact with essentially the proofs that he himself did give of the fundamental arithmetical laws from Hume's principle. Frege's own strategy, of course, was to use axiom 5, basic law 5, an axiom governing value ranges to prove Hume's principle, and then to prove the fundamental arithmetical laws from that principle. So our question then is, why didn't Frege adopt the Hume's principle strategy, that is, by to this question? And the answer in brief is called that adopting Hume's principle as the fundamental principle would not have solved what's called the Caesar problem, and I will say more about what that is. In this essay, I'm going to argue that that standard answer is wrong, and that that standard answer involves an importantly problematic view of Frege's realism. So that by seeing what's wrong with the standard answer to our question, we can get a better understanding of Frege's realism, or so I claim. So the standard answer is one that is, the reason I call it standard is that a large number of Frege scholars give exactly this answer. And so here is Michael Dummett. The problem that Frege saw with adopting the Hume's principle strategy was, as Dummett puts it, it affords us no possibility of determining the truth or falsity of a sentence like the number of planets is Julius Caesar. So any identity sentence that identifies a number phrase with something that isn't a number phrase like Julius Caesar. And here's the important part for us, and thereby fails to determine the references of numerical terms. This view, I take it, is also held by Crispin Wright, by Richard Kimberly Heck, by Bob Hale, by Jamie Tappenden, by a lot of people. The standard answer involves the following idea, that Frege held what we might call the Caesar condition, for want of a better term, on reference fixing, and this is the condition, that to fix the reference of a singular term t, it's essential to determine truth conditions for every sentence of the form t equals t prime, where t prime can come from fields entirely distinct from the theory into which we're introducing t. So t prime could come from a theory of Roman history, for example, if t comes from a theory of arithmetic. The first thing I want to note is that the Caesar condition is a very, very strange requirement on reference fixing for mathematical terms. Nobody, I take it, thinks that a theory of rational numbers, whose terms refer to rational numbers, must determine whether the rational number 2 is identical to the real number 2 or to the complex number, 2 plus 0i, or anything like that. When we do mathematics, we use our terms in a referring way, in a way that is completely independent of questions about whether those terms co-refer with terms from radically different theories. If the Caesar condition is right, then we're doing something badly wrong. And it seems to me this is an unusual view to attribute to Frege, who, after all, was interested entirely in mathematical discourse in the contexts that we're thinking of. So that's just an oddness of the Caesar condition, not really an argument against its attribution to Frege, but just a note about what an odd thing it would be to attribute it to Frege. Okay, and so our question is not, is the view odd, but did Frege hold the view? And so what I'm going to argue is that there are a couple of passages in Grundlagen that are standardly taken to be evidence that Frege holds this thing, the Caesar condition. I'm going to argue that these famous Caesar passages are pretty unclear. They can be read as expressing the Caesar condition. They can also be read quite differently, but that the overall treatment of number in Grundlagen is actually quite difficult to square with this interpretation of Frege's view. And finally, I want to turn to Grundgesetze, where things are much, much more clear. Frege's position in Grundgesetze is clearly inconsistent, I take it, with the Caesar condition and with the standard answer to our question. And just for those of you who don't have these dates in your mind, Grundlagen is 1884, Grundgesetze is 1893 and 1903. Frege gets the letter from Russell in 1902. So it's the view that Frege has in Grundgesetze that matters for the question whether or not his failure to adopt the Hume's principle strategy has anything to do with the so-called Caesar condition. And it seems to me it's just abundantly clear that it cannot, because he does not hold the Caesar condition by 1902. So that's what we're getting to. As I say, so Frege's reason for rejecting the HP strategy has nothing, I claim, to do with the Caesar condition. And finally, I take it that Frege's understanding of mathematical objects is really not quite as Platonist as it has often been taken to be. So, Grundlagen. So the two famous Caesar passages, let me just give you some context before we look at the texts. These Caesar passages appear during Frege's discussion of the requirements on a good definition of number. And so here are some preliminaries. Definitions, as Frege uses them, are always stipulations of notational convention. And so they have to be able to be used to license the substitution of a string of symbols for another, just straightforward definitions. And the goal in these passages is to define this. The number ... belongs to F. So this is, if we fix F, this is a concept phrase for Frege. It's something that has a gap in it into which one inserts a singular term. That singular term will, of course, typically be a numeral. The definition of NF, the reason to do this is that the next step is that Frege is going to use the definition of NF to license the replacement of that phrase by the definiens assigned to it by the definition in two important kinds of appearance. The first is where we put a numeral into that gap. The number 0 or 2 or 3, whatever, belongs to F. And the other is where we put a bound variable into that gap. The number X belongs to F, where X is a variable of the kind that ranges over objects, first level variable. Okay. So there's our phrase, the number ... belongs to F. And the importance of the second such appearance that I noted in the previous slide, that is the appearance in which one puts a bound variable in that gap, is that Frege will use it to define the concept number. And the definition just goes like this. We define the phrase X is a number as there is a concept F such that X is the number that belongs to F. So in all of these cases, we need to be able to put a bound variable into that gap. Okay, so as I say, the definition of NF must license the replacement of NF via a phrase that contains a gap suitable for filling with a proper name or object variable. And the definition of each numeral the 0, the 1, the 2, etc., must license its replacement by a proper name. Okay. Before giving his own favorite definition, the definition that's going to see him through to the end of Grundlagen, Frege gives two preliminary inadequate definitions of number. Each of these is rejected via one of the infamous Caesar passages. Okay, so that's the context of the Caesar passages. So what we're going to do now is look at the two definitions. The first I'm going to call the recursive definition, and then we look at its rejection via the first Caesar passage. Second is the thing I'll call the HP, the Hume's principle definition, and its rejection via the second Caesar passage. Okay, so the first, as I call it, the recursive definition to be rejected is this. We define the number blank belongs to the concept F by saying this. The number 0 belongs to F if and only if, and I've just underlined the definitions so you can see them more easily. If and only if, well, nothing falls under F. And 1 belongs to F if something falls under F, and all the A's and B's falling under F are identical. And n plus 1 belongs to F, generally speaking, if, well, something falls under F and n belongs to the concept falling under F, but not being that original thing. So these are exactly the kinds of translations that you might expect if all you're trying to do is to get the truth conditions right for instances of the number ... belongs to F if the ellipsis is filled in by a numeral for a finite cardinal number. Okay. But the first thing to note about this for our purposes is that the definition is, of course, an immediate failure. It doesn't license the replacement of instances of NF with a definiens containing a gap to be filled in by a proper name or variable. There are no gaps in my underlined phrases here that are filled in by a proper name standing for the number. So the proper names 0, 1, etc. in the instances of NF have totally disappeared in the definientia, as has the gap in NF itself. Okay. So here's Frege's description of the failure of that definition. We can never decide by means of our definitions whether a concept F has the number Julius Caesar belonging to it, or whether that same familiar conqueror of Gaul is a number or is not. It's only an illusion that we have defined 0 and 1. In reality, we have only fixed the sense of the phrases the number 0 belongs to, the number 1 belongs to, but we have no authority to pick out the 0 and 1 here as self-subsistent objects that can be recognized as the same again. I take it that the failure of the recursive definition to preserve the gap in NF, so that gap into which you're going to insert a numeral, is seen here by noticing that when we try to insert an arbitrary singular term, for example, Julius Caesar, into the gap, the recursive definition delivers nothing, right? So you cannot use the recursive definition to replace the phrase, the number ... belongs to F, in a sentence of the form, the number, and now put in an arbitrary singular term like Julius Caesar belongs to F. Why? Because our definition of NF didn't give us NF at all. It didn't give us a concept phrase with a gap in it. And we illustrate that by trying to insert an arbitrary singular term, here Julius Caesar, and recognizing that the definition doesn't treat this as a well-formed statement. So as a result of treating NF with its gap as a common feature of number attributions, the recursive definition has these failings. First, it blocks Frege's route to a definition of number, and it fails to treat number terms as proper names. So it fails in pretty much every conceivable way. The fact that the recursive definition fails to preserve NF's proper name gap is made vivid by noticing that the definition, as I said, makes no sense of the result of inserting an arbitrary proper name, that is, in our case, Julius Caesar, into that gap. Such an insertion is not well formed under the proposed definition. So the problem, it seems to me, is not that we don't have truth conditions for the statement that Caesar is a number, right? That's the ordinary reading of this passage. It's that we can't even form that statement. Okay, so does the Caesar example also show that Frege subscribed to the so-called Caesar condition, so that an adequate definition of number would have to provide truth conditions for statements of the form 2 equals Julius Caesar? Well, I want to just leave that question open for now. I am, of course, skeptical, as you'll know already. It seems to me we can give a perfectly good account of what's going on in sections 55 to 56 without attributing to Frege anything as weird as the Caesar condition. Is it possible to attribute to him that condition given the texts we've seen so far? Yes, I think that's true. Okay, second passage. Here, the proposed definition is what I'll call Hume's principal definition, the proposal to define, now this phrase, n equals the number that belongs to f equals the number that belongs to g as this. There is a one-to-one correspondence between f and g. Before looking at Frege's rejection of this analysis, it's important to note that it fails in exactly the same way that the recursive definition fails. It fails to make sense of the open sentence, the number ... belongs to the concept f, because again, this here, core, our definiens, doesn't give you the intended structure of NF. It doesn't give you a concept phrase, the number blank belongs to the concept f, and a singular term that can be filled in. And hence it's going to undermine Frege's strategy for defining the concept number. Okay, as the Grundlagen fans know, the text that Frege uses to criticize the HP definition actually criticizes the analogous proposal to define the concept direction via the definition as follows. We define the statement, the direction of line A equals the direction of line B, by setting it as shorthand for line A is parallel to line B. Okay, so that's the proposed definition, and we're about to see the text that criticizes that definition. Grundlagen 66. Frege says, in the proposition, the direction of A is identical with the direction of B, the direction of A plays the part of an object, and our definition affords us a means of recognizing this object as the same again, in case it should happen to crop up in some other guise, say, as the direction of B. But this means does not provide for all cases. It will not, for instance, this is my underlining, by the way, it will not, for instance, decide for us whether England is the same as the direction of the Earth's axis. The definition says nothing as to whether the proposition, the direction of A is identical with Q, should be affirmed or denied, except for the one case where Q is given in the form, the direction of B. What we lack is the concept of direction. So I take it that at least part of the problem with the HP definition is, as just noted, the account fails to make sense of the open sentence, ... is the direction of line A, and hence makes it impossible, as Frege says, to make sense of the concept phrase ... is a direction, at least in the way that would parallel Frege's own way of making sense of the concept phrase ... is a number. Frege's way of dramatizing this fact is, of course, to note that the insertion of an uncontroversial singular term, here, England, into the gap in D produces a sentence which, under the proposed analysis, cannot count as well-formed. So here too, at least as I understand it, the difficulty is that the definition fails to treat direction terms as occupying positions into which uncontroversial singular terms can be inserted. In so failing, it fails to treat directions as objects and fails to treat ... is a direction as referring to a concept. In short, the use of the term England in the rejection of the attempted definition of direction, I think, need not be seen as an endorsement of the view that a definition of direction must include criteria by means of which to distinguish directions from island nations. For it illustrates a much more immediate condition unmet by the definition, that it fails to treat directions as objects and fails to provide a relation phrase ... is the direction of line A that can be used to define the concept direction. Okay, our lingering interpretive question. Frege uses the terms Julius Caesar and England to make vivid the fact that the proposed definientia do not have a gap into which arbitrary proper names can be inserted. Question, does he also mean to convey that a successful definition of number must come along with criteria that will determine the truth values of sentences that link number terms with terms for example, Roman generals? Again, I would like to leave this question open. and look at two further parts of Frege's work in which I think things become much more clear. We'll just look at one more bit of Grundlagen, which is to look at Frege's own favorite definition, and then look at the much more clear treatment of number and of reference generally in Grundgesetze. Grundlagen, the definition of number. So Frege's eventual definition treats our target sentence, the number blank belongs to the concept f, as meaning blank equals the extension of the concept equinumerous with f. Okay, so that's the concept under which fall all of those concepts which can be put in bijection with f. So the earlier problem is solved. The gap in NF for proper names and variables is preserved, and the definiens here, NF star, is of the right form to be used in a definition of the concept number. Okay, so the complaint that, as I understand it, Frege was making in the Caesar passages against the initial rejected definitions is a complaint that doesn't apply to this definition, so that's good. But the Grundlagen definition does not satisfy the purported Caesar condition. The only identity sentences that receive truth conditions via the favored definition are those of this form. The number that belongs to f equals the number that belongs to g, and the number that belongs to f equals the extension of phi, for phi a second level concept. No truth conditions are given, for example, to the number that belongs to f equals Julius Caesar. So it's a bit difficult to think that the failure of the earlier definitions to provide truth conditions for this Caesar sentence was the reason to reject them. The favored definition doesn't do it either. This is an inconclusive reason to hold that Frege doesn't hold the Caesar condition in Grundlagen. Why is it inconclusive? Well, one might think that Frege is simply assuming that we all know that Caesar is not an extension. So that the sentence, the number that belongs to f equals Julius Caesar, is in fact provided with truth conditions by the definition of numbers as extensions. And this is perhaps what Frege is getting at in an equally famous footnote at this point in Grundlagen, in which he says, I assume it is known what the extension of a concept is. I actually think this is pretty unlikely for reasons that will come up when we look at Grundgesetze. But anyway, that's why this is not an entirely conclusive reason. Okay, Grundgesetze. So as probably most of you know, Frege's picture is that Grundgesetze is giving a very, very rigorous, careful version in Grundgesetze of the claims outlined in Grundlagen. There are some interesting changes, but the basic idea is that here we have a formal treatment of the informally treated content of Grundlagen. Okay, so just a couple of preliminaries. Frege insists on the following general condition of rigor, and this he insists on throughout his entire life, which we'll call the linguistic completeness requirement. That is, every well-formed series of symbols of the language of Grundgesetze must have reference. And so this entails that every sentence must have a truth value, every proper name must have a reference, and every function referred to in the language must be defined over every object treated in the theory. This is a requirement, by the way, that has a very, very nice discussion by Michael Dummett in his Frege Philosophy of Mathematics book. The idea here is that without meeting this requirement, one's formal system won't be up to Frege's standards of rigor, because we won't know that our rules of inference, in fact, it won't be true that our rules of inference guarantee the demonstration only of true sentences on the basis of true sentences. Okay. Notice, by the way, that this doesn't entail the Caesar condition, because what's required is that sentences, let's think about identity sentences for a moment. What's required is that every identity sentence of the language have a truth value. So if your language is a language for doing, let's say, real analysis, you need to be able to distinguish the real number 2. Well, you need to be able to solve the identity question that has a numeral for the real number 2 on one side and a numeral for any other number you're dealing with on the other side. The name Julius Caesar not being part of your language, the Julius Caesar question doesn't come up. Okay, so Grundgesetze. In Volume 1, Section 10, Frege deals with the following technical issue regarding value range names. By the way, value ranges are Frege's modern formal version of extensions. So as Frege notes, the introduction of value range names, together with Basic Law 5, has, up to this point in Grundgesetze, settled truth conditions on every sentence of the form, the value range of phi is identical with the value range of psi. And of course, the truth conditions are just this: the value range of phi is identical to the value range of psi, if and only if all the phi's are psi's and vice versa. Okay, but we haven't yet settled truth conditions on sentences of the form, the value range of phi equals q, for q not of the form, the value range of something. And so we haven't yet satisfied the linguistic completeness requirement. This might strike you as looking a lot like the Caesar problem, but it isn't. So here's how Frege puts the issue. By presenting the combination of signs, the value range of phi is identical with the value range of psi, as co-referential with, for all x, phi x equals psi x, we've admittedly by no means yet completely fixed the reference of a name such as the value range of phi. We have a way always to recognize a value range as the same if it's designated by a name such as the value range of phi, whereby it's already recognizable as a value range. However, we cannot decide yet whether an object that is not given to us as a value range is a value range or what function it may belong to. Okay, so this really is a purely technical issue. It is a matter of not having yet satisfied the linguistic completeness requirement. Here is the solution that Frege gives us to the problem. Again, this is Grundgesetze 1, Section 10. He stipulates the following. The value range of any concept under which just the true falls is identical with the true. The value range of any concept under which just the false falls is identical with the false. Let me just remind you that the true and the false are just the references of sentences for Frege. And that's it. That is the end of the stipulations that solve the problem. Because the only proper names in Grundgesetze are value range names, which will later on include number words because we're going to define the numbers as value ranges. Okay, the only proper names in Grundgesetze are value range names and sentences. The only cases that need to be treated are these two, true sentences and false sentences. That is, true and false sentences are the only proper names such that identity sentences linking value range names with them have not had their truth values settled by Basic Law 5. So we make this really small stipulation and we solve the problem. This very minimal stipulation is all that's needed, as I say, to make it the case that the value range names have a reference. And in case we were in any doubt about this, as I say, having made this Section 10 stipulation, Frege proves that every term of Grundgesetze has a reference. I say proves. In fact, as we all know, there is a problem with this proof. If there weren't a problem with this proof, the proof would actually prove the consistency of the system. And so we know there's a problem. And the problem is just that, I can talk about the problem later if you want. In any case, Frege takes himself to prove that every term of Grundgesetze has a reference in some fairly gory detail. A minimal picture of the details are as follows. First of all, Grundgesetze 1, Section 29 opens with the following question. When does a name refer to something? Okay, this is kind of our question, really. And here's the answer. There are 3 clauses here. The answer is this. Names of first level functions of 1 or of 2 arguments and names of second level or third level functions of 1 argument. Okay, those are the only primitive function names in Grundgesetze. Have a reference if, when you fill in their argument places by things that refer, the result refers. When does a proper name have a reference? It has a reference if, when you insert it into the or an argument place of a first level function of 1 or of 2 arguments, the result has a reference. So you might have thought, well, okay, so the idea is that a proper name has a reference if, when you insert it as the argument into any place it could go into in any function term, if the function term refers, then the result of putting the name in refers, which is roughly speaking Frege's idea. It's just that we're restricting ourselves to the consideration of first level functions of one or of two arguments. And you might ask, why? What about first level functions of three arguments or mixed level functions? And the answer is there are no such primitive function names in Grundgesetze. All we're talking about here are the names that there are. And these are, of course, recursive clauses. You're going to have some kind of basis clause. We begin with some primitive names of truth values that are known to have a reference. For example, for all x equals x refers to the truth. Once you've got those, then we use the first two clauses to give a recursive account of the conditions under which the other names have reference. And then we get a long, gory proof that every single name, function name, or singular term of Grundgesetze has a reference. As I say, in Grundgesetze section 31, Frege gives a rigorous proof that every name of the language has a reference. Okay, next, Frege defines number terms as value range terms. The number that belongs to the concept f, or the number of f's, refers to the value range of that concept, under which fall all the value ranges of concepts equinumerous with f. So, small detail, this is actually different from the Grundlagen definition. We are now taking numbers to be the value ranges of first level functions. So they're actually the first level functions under which fall, or first level concepts, under which fall the extensions of the concepts that are equinumerous with f. It's technically nicer to do it this way than to do it in the Grundlagen way. That the objects are not in any obvious sense the same, I think, is a very interesting feature of this reduction. And if anyone's interested, I can say more about that later. Okay, as a result, the following and their converses are the identity sentences involving number terms that have truth values in Grundgesetze. Those of the form, the number of f's is identical to the value range of phi, for phi, a first level function of one argument, including its subspecies, the number of x equals the number of g's, and the number of x equals complete sentence. That is it. Those are the only sentences involving number terms that receive truth values or even truth conditions in Grundgesetze. There isn't any way to form in the language of Grundgesetze a sentence like the number of f's equals Julius Caesar. And there is nothing about the term, the number of f's, that determines what the truth conditions for such a sentence would be. And you might have thought, well, this is a very incomplete way of fixing the reference of number terms. And so here's what Frege has to say. So regarding the arguably incomplete nature of the stipulations given in section 10, here's what Frege says. We have hereby determined the value ranges as far as is possible here. Only when the further issue arises of introducing a function that is not completely reducible to the functions already known, will we be able to stipulate what values it should have for value ranges as arguments. And this can then be viewed as a determination of the value ranges as well as of that function. So that is, I take it, if for some bizarre reason we were to expand the language of Grundgesetze by introducing into it the name Julius Caesar, and hence the function name blank equals Julius Caesar, we would at that point need to stipulate what value this function has for value ranges, including numbers, as arguments. But nothing said to this point will dictate the choice of stipulation. Nevertheless, as Frege says, every proper name of Grundgesetze, including, of course, number terms, has a determinate reference. Nothing about identity or distinctness from Caesar is relevant to this claim. So in short, in 1902, when Frege learns about Russell's paradox, he did not take it to be a requirement on numeral reference that sentences like the number of f's equals Caesar have either truth values or truth conditions. So at least by the time of Grundgesetze, Frege did not, I take it, subscribe to the Caesar condition. And his reason for rejecting the HP strategy in response to Russell's paradox cannot have been the so-called Caesar problem. So why did he reject the HP strategy? So here we need to look at the letter that Frege wrote to Russell on July 24th. And by the way, what I'm about to say about the reason for rejecting it is not something that is new to the literature. Michael Dummett, again, because I criticized him earlier, I should point out, he too takes it that this is part of Frege's reasoning. It's just that I take it it's all of Frege's reasoning. Okay, having thought about the paradox for a month, Frege writes to Russell that we can also try the following expedient, and I hinted at this in my Grundlagen. We have seen that hint today, by the way. If we have a relation phi for which the following propositions hold, symmetry and transitivity, so that is phi is an equivalence relation, then this relation can be transformed into an equality or identity, and phi of AB can be replaced by writing, for example, the such and such of A equals the such and such of B. If the relation is, for example, that of geometrical similarity, then A is similar to B can be replaced by saying the shape of A is the same as the shape of B. This is perhaps what you, Russell, call definition by abstraction. But the difficulties here are the same as in transforming the generality of an identity into an identity of value ranges. By the way, in case there's any students out there just beginning to read this stuff in Frege, if you're reading it in English translation, you need to be forewarned that the standard English translation has the word not, right? Oh, shoot, I'm sorry. Has the word not in the last sentence. It reads, but the difficulties here are not the same. And this is a typographical error. The difficulties are the same. Okay, so why are the difficulties with abstraction principles like Hume's principle? And I take it that's what Frege is alluding to in this letter. Why are the difficulties with abstraction principles like Hume's principle the same as the difficulties with basic law 5, as shown by the paradox? Well, prior to 1902, Frege often writes about the two halves of such abstraction principles as involving a very strong semantic similarity. Sometimes the claim is that the two sides express the same sense. So he says that once about basic law 5. Sometimes the claim is that they have a guaranteed identity of reference, etc. Always the idea is that we can unproblematically transform one side into another. So the kinds of abstraction principles he talks about are not just basic law 5 that says the value range of phi equals the value range of psi if and only if phi and psi give the same value for every argument, but also, as he said in the letter to Russell, the shape of A is identical to the shape of B if A and B bear geometrical similarity to one another, similarity of right, so parallel lines can be taken to have the same direction by a similar abstraction principle, and so on. So Frege is very interested in abstraction principles, and he really does seem to think that the transformation is one that doesn't require a special law. We're just taking the content that's expressed in the holding of an equivalence relation and, as he puts it in Grundlagen, recarving it into an identity statement. Arguably, this claimed self-evident semantic similarity between the two halves of an abstraction principle is what underwrites the status of basic law 5 as a law of logic, and underwrites the transformation, for example, of statements about geometrical similarity into statements about the identity of shapes. What we learn from the paradox, presumably, is just that this is false, that the two sides of an abstraction principle do not share the kind of strong semantic similarity needed to underwrite the inference from one side to the other. It is not a law of logic, one might say, that a statement of an equivalence relation can be transformed into an identity. So why Frege couldn't adopt the HP strategy? It seems to me that rejecting value ranges and adopting HP for the foundation of arithmetic would have posed 3 problems for Frege, 2 remediable and the one we've just seen, fatal. So remediable difficulty number 1. There is the problem that Frege himself points out in Grundlagen 66. Hume's principle cannot serve as a definition in Frege's sense, since it doesn't license the replacement of the phrase the number of F's by a definiens. In failing to assign to this phrase a singular term as its definiens, it fails to underwrite the claim that numbers are objects. The remedy here would presumably be to to do essentially what the neologicists have shown us is a very fruitful thing to do, which is to take the apparent singular termhood of numerals at face value, treat them as proper names, and just give up the idea of defining them. Adopt HP as an axiom, not as a definition. Remediable difficulty number 2. The language of Grundgesetze and the whole theory is intended to be not just about cardinal numbers, but about the reals. And perhaps in principle, as Frege says, of negative, fractional, irrational, and complex numbers. The appeal to value ranges, that is to say, Frege's actual way of defining these numbers, gives a way of smoothly treating the identity statements between these kinds of numbers. And this will be completely lost with the turn to Hume's principle for the cardinals. The remedy here, well, we will need a new kind of definition of the new numbers, and then we'll need to simply make some stipulations of the kind that Frege makes in Grundgesetze 1, section 10, to determine the truth values of these. So that is to say, you define the reals not in the way that Frege does it now as the extensions of some first level functions. Well, we'll define them in some new way. And then once we've done that, we will stipulate truth values for the identity sentences linking the singular terms for cardinals with the singular terms for reals, just more stipulation. But finally, the fatal difficulty, this is what we just talked about 2 slides ago, there just isn't a way from Frege's perspective to think of abstraction principles as truths of logic in the wake of the paradox. So I take it HP just can't be an axiom. Okay, a few remarks about Frege's views about number. So I think it's clear that Frege holds that a term T can refer, despite there being no fact of the matter with respect to some other referring terms T prime, whether the sentence T equals T prime is true or false. If T is a numeral and T prime is the name of a person, that's a good example. This should not strike us as particularly strange. It is the ordinary state of affairs with mathematical discourse. One might wonder, though, whether this picture of reference weakens the force of Frege's claim that numbers are objects. After all, you might have thought, well, if they really are objects, then there ought to be a fact of the matter, whether the names that they have co-refer with the names for other things. I think the answer is no. But it does undermine a particular way of understanding Frege's claim that numbers are objects. And I just want to say a little bit about that. So the problematic way of understanding Frege's realism about mathematical objects is this, that we explain our knowledge of arithmetical truths and of HP, Hume's principle, in terms of something like a conceptually prior apprehension of the objects in question. And to explain this apprehension of the objects, it's essential to explain how we distinguish them from, for example, people and islands. This is the picture that grounds the idea that the Caesar problem is a problem for Frege. This is how Hale and Wright give expression to what I think is the problematic view of Frege's Platonism. If Frege's Platonist conception is to be legitimate, there surely have to be facts of the matter about which objects the numbers are. The concept of number must possess sharp limits to its application. It cannot just be indeterminate whether the putative reference of the terms which Hume's principle enables us to introduce coincide with any previously understood or independently intelligible kind of objects. Hence, if there really are such reference, namely numbers, a satisfactory conception of the objects in question must somehow implicitly settle whether they are or are not trees, tigers, persons, or countries. So if what is supposedly a sufficient explanation or characterization of the cardinal numbers leaves such matters indeterminate, then either its claim to sufficiency as an explanation must be discarded, or Frege's Platonism must be. I think that a better way to understand Frege's realism about mathematical objects, and in keeping with what we've seen as his treatment of number terms in Grundgesetze, is as follows. The sense in which we apprehend mathematical objects is that we come to know mathematical truths that involve them. The idea that mathematical claims involve objects is just the idea that some of those mathematical claims are true and that their apparent singular terms are really singular terms, which is shown by the fact that they can appear alongside the identity sign in true and false sentences. They can be replaced by first-level bound variables and truth-preserving inferences, etc. They play the right role in quantificational inference. As to reference, following Frege's own strategy, one should say that one doesn't determine the reference of a mathematical singular term by somehow picking out an object independently of a surrounding theory and giving it a name. A name refers in virtue of playing the proper role in a theory, the kind of role that Frege has just known. The question which object a mathematical term refers to on this view is answered by explaining which sentences of the surrounding theory involving that term are true. The question how we distinguish the mathematical objects of a given theory from outlying objects, objects like England or Caesar, is not a question whose answer plays any role in a successful account of the grounds of that theory or of our knowledge of its truths, or so I think. So very briefly, some conclusions here. I think it is possible to read Grundlagen as expressing a commitment to the Caesar condition on reference. But this is certainly not the only reasonable way to understand the relevant passages. It is not possible to read Grundgesetze in a way that's consistent with the Caesar condition. So, as I've said, the Caesar problem is not Frege's reason for rejecting the Hume's principal strategy as a response to Russell's paradox. And I think we learn two things from this. Frege views the paradox as showing something problematic about abstraction principles in general. And Frege's view of knowledge about and reference to mathematical objects is really a fairly ordinary mathematical view that we are able to know about and refer to numbers and other mathematical objects simply by doing mathematics. And that is it. Thank you very much.
Thank you very much, Patty.
Can I ask an easy question?
No, Adrian, you were the first,
Right.
obviously. So please go ahead.
Well, my question is simply, did Frege write to Russell in German?
Yes.
Yep. Oh, yes, right. Because I think Russell spoke German, didn't he?
Yeah. Frege wrote to Russell in German, and now what I'm trying to remember, I'm sure someone else remembers, is my mind is going blank, is what language did Russell write back in? I'm pretty sure he wrote in German as well.
Right.
Yeah.
Yes. Thank you.
So Tim has a question.
Hi, Tim.
Yeah, nice to see. So the thing I've been wondering about is this, that it's how the kind of view that you're giving of the way the language works combines with the kind of explanations that Frege seems to be giving of ordinary first order quantification, which is something, you've been emphasizing that the range of proper names in the language is extremely limited. But when he gives an account of how ordinary quantification works, he seems to be giving a quasi institutional account where you're looking at the truth values of the result of substituting proper names for all the relevant objects, and so it seems that, as it were, even if he hasn't put all those names in the language, the language has got to be set up so that, as it were, without further ado, if you plug in a proper name for any of the objects that you're quantifying over, you get something fine, because otherwise the quantification itself would not be well defined. And so it seems that, as it were, whatever account he's giving of these expressions, they ought to be able to combine with, as it were, proper names for any old object that is being quantified over, which I take it Frege just means any old object, to give you a well-defined truth value, because otherwise there's a problem with his account of quantification.
Absolutely. Yeah, no, thanks, Tim. And I think that this is I think it's a very good question, and a question about which there is a real lack of precision on Frege's part. So first, with respect to his explanations of quantification, as you know, in both Begriffsschrift and Grundgesetze, there are bits where the natural way to think of what he's saying is a sort of substitutional account of the quantifiers, and other bits where it seems quite clear that he means something more objectual. So I think when reading these parts of Frege, it's important to keep in mind that he's trying to explain quantifiers sort of for the first time. And so thinking of the universal quantifier as being explained in terms of as it were, a property holding of all objects, or a concept name being satisfied by all names of objects, is something he just goes back and forth between. I think that you're absolutely right that fundamentally he has to think of his theory as quantifying over objects, not as having just a substitutional account. It does seem to me that he is thinking as a mathematician in the following sense. He takes his quantifiers to range over the objects of the theory in question. So at one point, when he's talking about over what we need to define the addition symbol, he says, well, if you're just doing integers, if you have just a theory of the integers, then the addition symbol needs to be defined just over the integers. If you have a theory of something broader, then your definition of addition must cover those as well. And I think that that's a natural way to think about the quantifiers for Frege. So keeping in mind that for him, a language is always completely interpreted, right? So he doesn't think as we do of the language and then application to theories with well-defined domains that you stipulate each time. You give me the language and we're already speaking it. It's already fully defined. So its range of quantifiers is already clear. I think a natural way to read Frege, though I don't think there's a great deal of support either for this view or for a contrary view in the text, I think a natural way to read him is as thinking that on each occasion of the use of the language, it will be relatively clear what the range of objects is that you're talking about. And that's what your quantifiers will range over. That's as clear as I can get. Now, what that means with respect to the language of Grundgesetze is an interesting question. So to be honest, I haven't churned through the definitions, I haven't churned through the proof enough to see what happens with the following sentence. For all x, there is a function f such that x is the value range of f. Does that come out to be true? And if so, exactly on what basis? It's got to have a truth value. And this is just because I haven't done the work. I don't think this is a deep mystery. I actually don't know what the truth value of that is. And that would be important to your question.
Yep.
Does that help?
Yeah, that definitely helps. But I mean, the worry, if he goes that way, is that he's achieving as much less than advertised, because I mean, this, he's supposed to be reconstructing the mathematics that we know and love, which can, for example, be used in doing applied mathematics, where you're talking about physical objects and then applying mathematical ideas to them in some way or other, and so that you might easily, in principle, as it were, have Julius Caesar or England in the range of the quantifiers, and then if the account that he's given is really only works for a much more for a language with a much more restricted range of quantification, then he hasn't really reconstructed the mathematics that we want.
Yeah, no, I think that's not a problem. I mean, so way back in Begriffsschrift, when he gives us his first formal language, he notes just how limited it is. And he talks about the further expansion of the language to cover, for example, mechanics. And I take it that's exactly what's going on with the language that he's giving us in Grundgesetze. It's the work of this book to figure out how to give the right deductive structure for a language that's going to be sufficient to prove the truths, as he calls it, of arithmetic. So number theory and real analysis. Once we want a language that's applied, that is to say, once we want to use the language to give a theory of mechanics or whatever, then nothing difficult happens. We simply expand the range of the names that we'll deal with. We expand the function names, add a bunch of stuff in for all the applications, and nothing other than new stipulations is going to cause any difficulty here, I don't think. So all of the fundamental truths, like, for example, if the number of f's equals the number of g's, then there's a bijection from the f's to the g's, that will stay true. So yeah, I don't think that the failure to have a universal language, let's say, means that Frege's conception of arithmetic is one that's not applicable. I think the picture is, yeah, add in the names of the stuff you want to talk about, make the right kinds of stipulations to make sure it's consistent and it's rigorous, done. Do you think that's satisfactory?
Well, I mean, you might, yeah, I mean, it depends, but I mean, you might worry that the stipulations that you were making were in some way didn't combine with what you'd already done, and and that it was something inconsistent. But I mean, it seems that you'd need quite an elaborate story about what extra work needs to be done. I mean, because it doesn't need to be anything as sophisticated as mechanics. If you want to use arithmetic to say that if you have 5 Roman generals and 7 Roman generals and no general is 5 Roman generals and 7 Greek generals and no Roman general is a Greek general, then you've got 12 Roman or Greek generals. I mean, it seems that just in order to use arithmetic to do that, we'd suddenly have to start making a mass of further stipulations, which was kind of not what we were expecting. I mean, it doesn't feel terribly Fregean to me, but I'm not saying that it couldn't be done.
Yeah.
Okay, so I have Ian Rumford in the chat.
Oh, Ian.
Hello, Paddy. Thank you for a very nice talk. Yes, I think I'm sympathetic to the negative part of your paper, the idea that we don't have a good explanation of why he didn't go down the agency routes in terms of the demand, the universal demand for truth conditions for identity statements. I was a bit puzzled by the positive proposal just in this way. So as I understood it, you were saying that what he took from Russell's letter was primarily the idea that the sort of justification he'd given earlier for transforming universally quantified statements into identities was not going to fly. Is that right? Yeah.
Yes.
Yeah. And I mean, no doubt that's right, but in one way, but I suppose what I find odd about that as an interpretive thesis is that justification that he gives, you thought wouldn't have flown anyway after 1891. So the justification he gives for this in Grundlagen, as you said, relies very heavily on this talk of recarving content. And the notion of content in Grundlagen hovers in some strange no man's land between what he later distinguished between the realm of sense and the realm of reference. It doesn't seem to me that what he says about recarving content fits nicely into either of the categories that he later distinguished. I suppose my question is this, why do you think he imagined that justificatory story would survive the distinction in the earlier notion of content into the later notions of Sinn and Bedeutung? It seems to me that it sort of falls flat there at that point, long before he gets a letter from Russell.
So I take it the reason one might think it falls flat is this, might think that when we're thinking about the fairly coarse-grained things called contents of Grundlagen, the idea that the left-hand side and the right-hand side of an abstraction principle might express the same content seems plausible.
Yeah.
But the idea that the left-hand side and the right-hand side of an abstraction principle express the same sense seems less plausible. Is that
exactly? Yeah. And
yeah.
like sharpen it, it's surely inconsistent with some of his theses about sense. So when he says, that the structure of the sentence reflects the structure of the thought, it seems from his perspective that a universally quantified biconditional is going to have a very different structure from a statement of identity. So they can't both be reflecting a single Fregean Gedanke.
I think they can, in fact. So yeah, two things. I don't think that the idea that the structure of the sentence reflects the or a structure of the thought means that a thought is decomposable in only one way. In fact, I think the idea of multiple decompositions of thought is actually a fairly robust thought throughout Frege's work.
Yeah.
But more to the point, so the question is, can he make sense of the idea that the two sides, I'm sorry, that's my dog in the background. Can he make sense of the idea that the two sides of an abstraction principle are, the way I would like to put it, are sufficiently similar that it's a principle of logic that you can infer the one from the other?
Yeah.
And it seems to me that he does think this. So in 1891, now it's either the function and concept or concept and object paper. I'll find it for you if it's not easy to find. He does say that the two sides of a particular instance of basic law 5 do have the same sense. Now, that seems to be the only time when he says this, but there's one. Later, he gets a bit more cautious, and I think it's probably for the kinds of reasons that you have in mind. Sense is becoming, in his mind, a slightly more fine-grained idea. That is to say, the senses of two sentences are the same only under more narrow conditions.
Yes.
What's important here, I think, is whether or not the senses of the two sides of the abstraction principle are sufficiently similar to ground the claim that the principle is a law of logic. How similar do they have to be? Who knows? And here I think one simply has to say, first of all, Frege never gives clear identity criteria for thoughts, and never, that is for senses, never gives clear identity criteria for senses. I think that there are different strains that we can find running through Frege. Sometimes they're more coarsely grained and sometimes more finely grained. He also never gives a clear statement of the question, what's required by way of similarity for two sentences to count as logically equivalent. So is it coherent with Frege's view of sense, thought, and logic that the two sides of an equivalence relation, like the abstraction principles, could express senses that are sufficiently similar that it's a law of logic that binds them? I think yes. I also don't think it's very clear what he thinks is required for something to be a law of logic. Here's my picture of what's going on with the attempt to reduce the theory of arithmetic to a theory of logic is this. Frege thinks his audience is going to grant him that things like modus ponens and the self-identity of every object are laws of logic. These aren't claims he defends. He thinks we will just start from admitted laws of logic. And he thinks that something like the inference from one side of an abstraction principle to the other is also something which, at least in the case of extensions, is common ground. Everyone does this. So these he takes it are principles that his audience, I think, will simply grant as logical principles, and then he goes from there. So the question, what makes them logical principles, is not something that we ever find him talking about particularly clearly. So I don't know if that helps, but yeah.
Well, yeah, up to a point, as they say. Yeah, I mean, I do. I certainly think he has the notion of multiple decomposition, but I'm not sure that you know the stories he tells about that, notably in Begriff Shift, when it first comes up, really extend to as far as two admissible decompositions being, you know, one is as you put it, direction equals direction of B versus the lines are parallel. I mean, yes, there is that statement where he does say that they express the same thoughts. But I think you're right in saying that's the only flat-out claim he makes in the whole of the corpus, and so one could sort of wonder whether that's just an obiter dicta, really. But
yeah, one could. Yeah. No, I understand. I agree. There's a tension here.
Okay.
Yeah. Thanks, Ian.
Thanks.
I don't have anyone else in the chat, so
Okay, I wanted to ask a question. I don't seem to have managed to get into the chat. I was very struck by your account of what the, well, as it were, what Frege's view about ontology was in relation to mathematics, that he was much less concerned with saying which particular things an object was apart from the theory in which one considered those objects. I mean, you made this striking point about the fact that the theory of rational numbers isn't going to tell you whether 2 is a real number or not. But then it seemed to me that if that is a view that can be attributed to Frege, then it seems to me not so clear why he doesn't accept the Hume's principle, well, why he doesn't accept Frege arithmetic as a very good account of arithmetic, because it's a way of doing arithmetic. He saw it himself, and people emphasize this fact. So if you take the view that what it is to know the objects of a particular theory is to know what's true or false about things that involve those objects, then it seems to me that that's an account that would say that for Frege arithmetic should have been a perfectly good account, and then makes it puzzling why he didn't embrace that way of looking at ontology.
Good, thanks, Dan. I think that's a really nice question. And to be honest, I think that if all Frege wanted was an account of how ordinary people or number theorists refer using numerals, Frege arithmetic would be fine. I think the logicist program is intended not really to answer that question, but to answer the question, what are the grounds of the truths, knowledge of which suffices for example, using the numerals to refer. So number theory before Frege's reduction was, I take it, perfectly good, unproblematic. Its numerals referred, even though nobody had done anything like a reduction to logic. But once one realizes that Frege arithmetic is arithmetic, right? Then the question is, so is this a theory that has any deeper grounding? And Frege's view is, yes, it does. It is grounded in it's grounded in logic, he thinks, until 1902. And so the question is, so what does that have to do with the objects? And I think it has not very much to do with the objects. You do not have to think of the numbers as extensions or as value ranges to know what the numbers are. Identifying the numbers with extensions or value ranges is a part of embedding number theory within a more general theory, a theory of logic, and showing that you can prove the number theoretic truths from more primitive truths. So I think there's a really important separation for Frege between the following two questions. First question, what are the most general, most fundamental truths from which we can prove all of the truths of arithmetic? Secondly, what is it about arithmetic that makes its numerals refer? And I think the answer to the second question can be given by saying, well, it's just arithmetic. It's got the following features, and looking at it in terms of its being Frege arithmetic is perhaps the right thing to say here. The question, what are the most general, most basic truths from which one can prove all of arithmetic? That's got a very, very different question. Sorry, very, very different answer. And while the Logicist project is going on, the answer is logic. Post-Logicist project, the answer tentatively from Frege is geometry. So he's just looking for a broader theory whose grounds are more straightforward. He thinks that there is something called the logical source of knowledge and something called the geometrical source of knowledge. He's a good Kantian. And he would like to explain arithmetic in terms of one or the other, preferably the first. I don't know if that helps answer your question.
Well, yes, I mean, it does, but I mean, the issue of whether, well, so-called neo-Phrygian logicism is a form of Phrygian logicism.
Yeah.
I mean, we haven't addressed that directly, but it seems, well, from your perspective, it seems that the answer should be no.
It's no.
And it's clear it should be no in this sense, that for Frege, the Logicist project is to show that arithmetic, the truths of arithmetic are analytic in the sense that they're derivable from logic plus definitions. Frege arithmetic does not satisfy that criterion, because clearly Hume's principle is not analytic in that sense. Yeah. And arguments that it's analytic in some other sense, like Carnap's, which is in effect what the neologicists are arguing, doesn't seem relevant to that
I agree.
question. So it seems like in the end, one has a situation in which Frege arithmetic is absolutely fine, of course, and a perfectly good way of understanding arithmetic. But it remains a fact that Frege's hope for as logicism in the sense of establishing that the truths of arithmetic are reducible to logic by definitions turned out to be unachievable, and there's no way around that.
Yes, that is exactly what I would say. Yeah. So I think the Neologicist project is a fascinating project. I don't mean to be dismissive in the least, but it is certainly not neo-Fregean in the sense that, exactly as you put it, Hume's principle is not a principle of logic, and it's not a definition. And so grounding arithmetic in Hume's principle plus logic is not a way of doing what Frege would have called grounding arithmetic in logic. Yeah.
And I mean, of course, basic law 5 did look like a principle of logic.
Yes, exactly. It really does. You know, were it not for the paradox, we would all be logicists.
Yes.
Not me.
Okay, never Volker.
Any other question? I mean, I have nobody in the chat. Maybe there's a technical problem, but yeah. Would anyone like to ask a question? So I don't see anyone. So let's thank Patty again. Thanks, Patty.
Thank you, Volker. Thank you, Daniel. Thank you, everybody. Nice to see you all.
Yeah.
Maybe next time in Oxford.